minus 0.7, minus 0.49. Isn't it? We'll have to do it at least for one other quadrant, either third or fourth. Otherwise, our concept won't be clear. If we do it for the third quadrant, when Z10, Z20, both of them are negative, then what would happen? Is it clear? This one for all of you? Now in the third quadrant I am going to draw. Okay. Any doubt so far? Anyone? So this is my choice 3. This is choice 2. Earlier we had choice 1. So for that again we have to do the same thing. Fine, we are starting from this point. After that, now you guide me how to draw. Now only thing is the same relationship works. Now here that is you can say that is sir now like Z1 all are negative, Z1 square they are positive, but my equation says Z2 must be negative for all t greater than equals to. How come it is possible? Because you have C as well. Okay, so that is the reason. So in such cases, definitely you would have confusion. That is, if you try to find out the sign of Z2 only from that relation. So that is the reason why I said that you always come back to the first two equations, which are the fundamental ones, 1 and 2. So both of them, here you see Z10, Z20, both of them are -1. So for them, whatever may be the other derived relationship, the fundamental ones cannot change. So here that is Z10, Z20, both of them are -1. So of course Z1 and Z2, they will remain negative for all positivities, right? So now the numerical values will remain the same, only that is they will be preceded by a minus sign. Because now Z1 all of them negative values, Z2 all of them negative values, right? Only that would be the added thing. So that's why in the first case I drew the graph on the first quadrant, in the second case I drew it on the second quadrant, now on the third quadrant. But please remember the numerical values will never change, they will be the same. Okay? Why they will remain the same? Because here there is no change. Only that is we are playing with the plus and minus, right? Because initial condition we kept, that is from 1 1 we changed to -1 plus 1. Now that is we are going to draw for -1. Okay, so its magnitude didn't change. So that's why in the numerical values of Z2 and Z1 there won't be any changes. Only the change will with respect to the sign. Okay, so for -1 it is -1. After that for -0.9 it will be -0.81. Then for -0.8 it will be -0.64. And for -0.7 it will be -0.49. For -0.6 it will be -0.36. For -0.5 it will be -0.25. For -0.4 it will be -0.16. And for -0.3 it will be -0.09. Did you see? That is the reason why in the books when they write it, when they show it in general, they usually show in this pattern. For and again for different initial conditions it could be like this, and if someone asks you that is which is the stable node here, the origin is the equilibrium point, which is stable node in this case? Node means that everything is attracted toward that point and it is asymptotically. Okay. Now that is, if you see the book, they also shows that is these four, like here we haven't yet done that, but according to the book they say that is there will be four straight line loci. This one, this one, this one, this one. Are you sure about that? This is about the last bit. So, Moina, or you throw? Oh, yeah, the important class miss होएगा. Vishwanath, এটা বড় দেখি কি মনে হয়? That is now we are going to do the last bit, that is about these four different initial conditions. Okay, suppose four different initial condition means if it is 1 0 0 1 minus 1 0 and 0 minus 1, what will be the situation? So what I wanted to mean, suppose here you have a point, this is 1 0. Here you have a point 0 1. Similarly here you have a point minus 1 0. The last one here you have 0 minus 1. Then how to decide? Tell me.
C will become 0 or infinite in the C which depends on the initial condition will become 0 or infinite, and based on it the
Here we have a very important point to think about. Please focus on this. Should exist in R. So that is, if we have something that is where Z10 is becoming 0, for those kind of relationship, this equation or this relationship doesn't exist. Please don't make the mistake. Once again, that is, if you have an initial condition for which like C is going to infinity, then it is an absurd thing, right? So for such kind of initial conditions, this relationship doesn't hold. So that's why today, like last day I missed that one. Today specifically I mentioned should exist in R. That means C must be a real number. It may be 0, but it must be a real number. It should not be infinity, because infinity is not a real number. Okay? So then how to decide? Please remember, whenever you have this kind of initial condition which is very stringent, because one of the coordinate is present, other one is simply absent, then we don't even need this relationship. You directly that is go back to the solution. And how? Let's say that is you have that is 1 0. So if Z20 is 1, then Z2t equals to 0, that is it is identically 0. Z2 will remain 0 for all t greater than equals to 0. And then what will be my locus? Then it is only, it will be decided by Z1 e to the power lambda 1t Z0. So that is this will continuously taking from 1, then 0.99, 0.98, 0.97, that is till it reaches 0. Because all those points, suppose at this moment it is 1 0, then 0.990, 0.980, then 0.9, 0, 0.8, 0, up to 0, 0. So that's why now the full traversal would be following this Z1 axis only. Okay, that is the reason for this locus. Please tell me whether this is fine for all. Kanika, is it fine? Kashif, बोलो, कुछ डाउट है तो बोलो. जैसे Z20, when this is equals to 0, that means your Z2t equals to 0 for all t greater than equals to 0. We do not have any doubt about it. So now whatever may be your locus, what could be the option? Because Z2 is continuously 0. So do you remember in the school days we usually had this kind of thing, that is what is the equation of the exactly, what is the equation of the y-axis, or even what is the equation of the x-axis. So here it is kind of completely the z2 values are 0. So you cannot expect any point or any line other than on the z1 line, isn't it? Here you have z1 values, fine, and that is a continuous, like starting from 1, because z1 you still have the same graph. Starting from 1, that is simply e to the power minus t. So it is a continuous graph, so one by one all the points, basically you cannot mention individual points, it is a continuous graph starting from 1. So all those points, whatever you are getting with respect to the t, they will be plotted on this line. Why? Because only on this line you have z2 equals to 0, isn't it? Now that is, if you check the other one, 0, 1, then what will happen? If z1 0 equals to 0, then z1 t, that will be identical equals to 0 for all t greater than equals to 0. But what about your z2? Now z2 will be the same thing, e to the power minus t. So starting from 1, it would be then continuously all those points, and that is, it will stop only when it reaches the origin. Once again, that is 0, 1, that means z1 0 is your 0. So z1 of t, that will remain 0 for all t greater than equals to 0, isn't it? Only z2 will vary according to the relationship this, e to the power minus t. Okay. So then e to the power minus t for whatever values, starting from 1, then 0.99, 0.98, 0.97, so on so forth, they will be plotted on this line, because you cannot go anywhere else. Because like if you wish to plot at somewhere else, definitely it will grab a non-zero z1 value, but data z1 is 0. Then if you consider this one minus 1, 0, again z2t will be 0 continuously for all t greater than equals to 0. And what about your z1? In this case, what is your z1? z1 of t, that is equals to minus e to the power minus t. That means starting from minus 1, then minus 0.99, minus 0.98 up to 0. So all the points would be on this line only. Is it fine? And similarly the last one, 0, minus 1. So z1 0, 0 means z1 would be identically 0 for all t greater than equals to 0. And now my z2 t equals to minus e to the power minus t. So starting from minus 1, similarly, that is, all these values would be plotted on the minus z2 line, and it will stop only after reaching the origin.
So minus e to the power twice, minus twice.
Sorry, yes, ma'am. So that's why, although all other remaining graphs would be like a different kind of parabola or conic section, but these four will be straight line. Okay. So this is the construction of the phase plane trajectory only for the first phase. That means after taking so long time, we could do only, that is, one. But I hope that is, once this fundamental knowledge is clear to you, after that we can speed up. Now you tell me whether all of you are happy or not. Like this month, that day, you were also not happy. So today, is it now fine? Because you said in one other book it was a bit easier, so then I thought that it's okay. If a PhD student says that
no,
it is showing
tough, I told there are a lot of examples in that book. So that's why I told. Actually in Slocum and Khalil they are showing the abstract idea. So that's why I told.
No, that is the reason why I said that is, if you study any nonlinear control book, actually it is so mathematical, like still plotting book is easier, but you see, that is why this learning this phase plane plot, we spend almost more than 1.5 hours, right? Still we could do one, but this is not possible to cover in a book. That is the difficulty. But I think that this exercise is a brilliant one for all of us, because we all are beginner here, and this will create, that this will help to develop your fundamental knowledge. That is what is phase spread analysis and then how do you do it. Okay. And only that is one thing I couldn't do, that is the plotting of square root of z1 and then cubic root of z1. That you please do. That is, please get a snap of the board and then you plot. I'm sure that this will come like this. And like today, that is like after the end of the classes and in the evening, please sit with this and try to be confident, because like we don't have that much of time to do the same justice for all. Okay, so that is, we would be needing this knowledge for drawing the remaining ones, because for the remaining ones I'll have to depend upon the relationship and I will be drawing directly. We will discuss, but we won't have that much time to draw it from numerical values. Okay, I do not.
Yes, sir.
How is it? Is it fine?
Yes, fine, sir.
Totally? Digesh korbo kintu what about you? हुआ क्या नहीं हुआ? Now, can anybody tell me, that is, if it is instead of this, Vishwanath, suppose it is lambda 1, lambda 2, if they are plus 1 and plus 2, then what would happen? That means now they would be diverging. How would you decide?
So equations 1 and 2 e to the power positive values, which is exponentially increasing.
That means now there is only one thing. See, still you may have a doubt. That is, here we have the same relationship, but how would you now get the values of z1? So if it is suppose plus 1, then earlier we drew that is e to the power minus t, right? E to the power minus t. That now if it is, if lambda 1 equals to plus 1, then it would be e to the power plus t. It would be sharper, it would be steeper, I think. So now earlier I considered these values 0.9, 0.8, 0.7, but now the set of values would be completely different. So it would be after 1, it would be certainly, that is, like suppose e to the power, then after 1 what would be the value? Maybe 1.1, 1.2, 1.3, and then similar square values of them. So if you still choose the same point 1, 1, then starting from that it would be like this. And now that is, if you consider, like suppose the point is 0.1, 0.1, say for here, then you will find that is, it will take the same kind of graph, but it will go upwards. So that's why in the book usually they just draw, like for lambda positive, like if both of them are unstable, then they show the same graph with only these arrows becoming upward. Okay. But please note that if you have to do that, then the initial condition, that is, you have to fill the whole line, right? Because that's what I say, that is, if you still consider the same point 1, 1, then you don't have this much portion, because starting from 1, it would be taking the higher values. So if the point is 1, then it would be like this. You don't have any locus here. But if you then simply extrapolate the graph, then it will go like this. Okay. Is it fine? Anybody, any doubt? At this moment, please check your notebook. All of you take 1 or 2 minutes more time, check the entire thing. I'm still here.